Hose pumps and diaphragm pumps are both commonly used pumps in industrial applications. They are widely used in industries such as chemical processing, environmental protection, mining, and food production, although both can be used to transfer corrosive media, particle-containing liquids, and high-viscosity materials. Particle-containing liquids and high-viscosity materials. In terms of structural features and suitable working conditions, there are still significant differences. The working principle of a hose pump. It works by continuously compressing the hose through the rotation of the rotor, so that the medium is conveyed forward inside the hose. Throughout the entire conveying process, the fluid only comes into contact with the hose, and does not come into contact with any other internal mechanical parts of the pump body. Therefore, hose pumps have excellent sealing performance. As long as the hose remains intact, it can basically achieve leak-free conveying. For strongly corrosive liquids, hazardous chemicals, and industries with high hygiene requirements, this advantage is very significant. In addition, hose pumps are well suited for high viscosity and particle-containing fluids, and also have relatively strong adaptability to abrasive and wear-prone fluids. For example, complex media such as slurry, sludge, and particle-containing suspensions. Hose pumps can usually convey these media stably, and are not prone to clogging. It also has good self-priming capability, and can even tolerate short periods of dry running. Therefore, it offers relatively high stability under complex operating conditions. Diaphragm pumps, on the other hand, operate through a diaphragm, which moves back and forth to change the volume of the chamber, thereby achieving suction and discharge of liquid. Common types include air-operated diaphragm pumps and electric diaphragm pumps. Diaphragm pumps have a mature structure and a wide range of applications for general chemical liquids, wastewater, and moderately corrosive fluids. They all provide good conveying performance. However, diaphragm pumps contain an internal diaphragm, multiple wear parts such as ball valves and valve seats. Over long-term operation, they are prone to wear, leakage, or clogging issues, especially when handling large particles or highly abrasive media. Maintenance frequency is often higher than that of hose pumps. In simple terms, when operating conditions are complex, with high viscosity media and a high content of particles, or when there are high requirements for sealing performance, then hose pumps are usually more suitable. For routine liquid transfer applications, however, either option can be suitable depending on the specific requirements. Where cost control and standard operating conditions are more important, then diaphragm pumps are also a good choice. In fact, there is no absolutely better pump, only equipment that is more suitable for the specific operating conditions. When selecting equipment, it is still necessary to consider the properties of the medium, as well as conveying distance, pressure, and overall maintenance costs.